Hi, this is Jacob Nash with JNGL, and today we are on a new unit, that is Unit 2, Lesson 1. And this one's not really a whole lot about math, it's just logic and conditional statements. That sounds really boring, and it might be, but that's just what it's going to be for this time. And once you get it, it will be simple, and then we can go on to the other things. Okay, first, a counterexample. This is an example that shows that something is false. So, this is pretty simple. Can you think of a counterexample for this statement? Two odd numbers added equal an odd number. Can you think of a situation when that wouldn't be true? All you have to say, you can either say true if it's true all the time, or say false and then y. So, or you could just write T and F. Well, I can tell you that this is false for every situation, because anytime you have two added odd numbers, it always equals an even number, not an odd number. So you could say for the counterexample, f, and then comma, and then you could write your counterexample. And there's a whole lot. You could say 1 plus 1, that's 2. You could say 3 plus 7, that's 10. Or 3 plus 5, that's 8. That's what it is. Okay, good. A conditional statement. These are if-then statements. You've probably heard of those. But it's a little different than what it's like in maybe science or whatever you've heard it from. Hypothesis. Well, you usually think that's just an educated guess. But it's not the same in geometry. It's just, all it is the part that comes after the if, the word if, not including it. And then conclusion is the part that comes after the then, not including it. So I showed how this is. So with the P's and Q's, maybe that's what that comes from. Mind your P's and Q's. I don't know. But P stands for the hypothesis, and then Q is the conclusion. And I messed up a little bit right here because it actually it doesn't include the then, so sorry about that. Sorry if it's a little loud, because I have other siblings and they are playing their radio right now. Okay, so anyways, here's the next thing. Converse. Converse is when you switch the hypothesis and conclusion. Let's see. Yeah, so anyways, that's a conditional, and then converse is kind of just reversing it. You see verse, you think reverse, maybe. So this is just making the P after the Q. So if you're doing a conditional, it's PQ, but if you're doing converse, it's QP. So there you go. So you might be asked to come up with the converse. You even might be able to find a statement and have to come up with the conditional and converse. But that's not being discussed in this video. It's just the basics. That's all the time I have. Alright, conditional. If two angles have the same length, then they are congruent. What is the converse? Okay, well this is the Q, this is the P. We want to reverse those. Now, it does make sense if you say, if they are congruent, then two angles have the same length. You have to reword it a little bit for it to make sense. Because if you start out with saying they, you have no clue what to say. So I'm going to just do a text box because I don't really want to write that all. So here's what it is. You say, you still keep the if and then, but you say if two angles are congruent, then they have the same length. You see? Listen.
If two angles are congruent, then they have the same length.
You hear that?
If two angles are congruent, then they have the same length.
Good. That doesn't matter, but so there you go. I reworded it a little bit, and I put the two angles first so that you would know what it was talking about when they got to the they. So that's how it is. Yeah, that's simple enough. And then biconditional statement. This is a statement that uses the words if and only if. And they are a conditional and converse combo. So if you have conditional and converse and you need to make a biconditional, there are steps to doing it. But first let's talk about this if with the two F's. This means if and only if. That's just a way of abbreviating it. So if you see if, that means that. So 2 points are complainer if and only if. That's what that means. They lie on the same line. Okay, well, we want to create a. Well, actually, that is the biconditional. Sorry, but if you wanted to, then this is how you would do it. There's 3 steps. First, you take either the converse or the conditional that you know, either one, and then you take away the if and then you replace the then with if and only if. So if you wanted to change it back, all you would have to do is take out the if and only if, replace it with a then, and then put an if back there, and then it's back to normal. Okay, next. So now we have 2 laws that we'll go over. The first law is law of detachment. Let's see, did I skip something? I feel like there was something that I maybe skipped. Nope. Okay, sorry about that. Thought that I might have. Alright, if P to Q is true, then P and Q are true. So, basically this just means the conditional, because that's P to Q. So if the conditional is true, then we know that the if statement and the then statements are true. That's all that means. Anytime there's a law, it just is saying this is what's going to be true all the time. And it's the postulate, remember that? Okay, so here are 2 examples to show. So, example 1 is, if it is cold outside, then I will wear my jacket. So this is what the logic is. You have to find out what you know from the statements. Okay, so if it is cold outside, then I will wear my jacket. On Wednesday, it will be cold. So what do you know from that? You could say, I know something from it, or you could say, I don't know something from it. But how do you know if you can find something from it? Well, it's if you take the 2, there might be like 2 statements, and you take the first part of both of it. So it is cold outside, and then it will be cold. Do they match? Yes. It's still talking about the same thing, cold and cold. So you know that you can get something from this. That's how you know. And what do you know? If you know that when it's cold, you wear a jacket, and that means that if it's cold on Wednesday, that you will wear the jacket. That's how simple it is. I will wear my jacket on Wednesday. There you go. That's all you need to know for that. And then example 2 is, if you do your chores, then you can go to Sir Nasher's house. You didn't do your chores. So remember, there can be a conclusion or no conclusion. Well, let's see about this. Do things match up? You do your chores. You didn't do your chores. Do those match up? No. Now, this is what's the hard thing. Most of you might have thought that means you're not going to Sir Nasher's house. But that doesn't necessarily mean that, because all we know from this sentence, like, just pretend like you don't know anything, any possibility but what it says in here. You only know what will happen if you do your chores. It doesn't say what will happen if you don't. It didn't say if you don't do your chores, you won't go to Sir Nasher's house. It says that if you do, you will go to his house. So that's how you know that there is no conclusion that can be drawn from this, because you have no clue what will happen if you don't do your chores. You might think that that you won't go to Sir Nash's house, but that's just a theorem. It can't be proven. So that's how you know there's no conclusion. 7. Okay, this is the next law. Law of syllogism. I am pretty sure that's how you say it. So this means if P to Q is true, and Q to R is true, etc., R to S, S to T, then P to R is true. Well, what this means is if the first statement that you hear about is true, and then the second one is true, then the whole thing must be true. And if you don't understand what that means, let's look at this example. If I see Mr. Brown, then I say hello. If I say hello, Mr. Brown says hi back. If Mr. Brown says hi back, I am in a good mood. If I am in a good mood, I make better grades. So it's sort of like a chain, like each thing goes with the other thing. So this is the first thing that happened. If I see Mr. Brown, and then I make better grades. That's how you know. That is what can be drawn from this. What can be drawn is that if I see Mr. Brown, I make better grades. Now you can't necessarily it doesn't exactly say that in this paragraph straight off, but we know that all these things are true, so they have to be connected to each other. If it just said if I see Mr. Brown, I say hello, and then if I am in a good mood, I make better grades. If it left out these two sentences, that would mean no conclusion, because they don't go together. If I'm in a good mood, I say hello. That doesn't go together, because that just doesn't work. So that's an example of when that wouldn't be true. Practice. Well, there doesn't really need to be practice for this one, because it's kind of just a logical thing, and there's not really something you need practice. Now, if you really don't understand it, then you can practice it, but that is just not what I was going to do for this one. So, thanks for watching. Yeah, there we go. Thanks for watching. Good. Yeah. Thank you for watching this video. Stay tuned for 2.2.